Today, we are demonstrating the Zero Defect Manufacturing or ZDM use case for the 5G DIVE project final review. Specifically, we will investigate the aspects of 5G connectivity and mobile edge computing for intelligently detecting and disposing defects in a factory in real time. Additionally, we will show the use case integration with the common deep platform of the 5G DIVE project. The goal of the ZDM is to automate the control of a factory. The factory is monitored using a high-resolution camera. The video captured by the camera is streamed to an edge node with multi-axis edge computing capabilities to process that video stream and provide decision-making for the automated control of that factory. Our ZDM use case is a two-part setup, a factory side and an edge side. At the factory, there is a robotic arm mounted on a sliding rail. The objects or goods being manufactured, a conveyor belt, a disposal bin, an HD camera, and an on-site control device or a fog node that gives commands to the factory equipment. The camera is capturing a high-resolution video and streaming it to the edge node over the 5G network using a CPE as a gateway. In this demo, we use the commercial 5G network. At the edge side, there is an Xavier computing node that has a trained YOLO engine capable of detecting objects and categorizing them as defective or non-defective. In this demo, we use cubes as the main product of the factory, where we trained our AI system to detect the cubes having black circular marks as defective, while monocolored cubes are detected as non-defective. The fog node at the factory side has a Python code that controls the production line and receives command from the edge node to dispose defective objects or leave non-defective objects on the conveyor belt. The edge node has, in addition to the YOLO engine, a Python script that sends commands to the factory side whenever an object is detected. The ZDM deployment is automated through the bus using Eclipse Fog05 driver for the fog and edge node. The bus instance runs from the common bus platform at the 5Tonic lab in Madrid. Here we can see the bus common instance in the 5Tonic lab. By pressing deploy, the bus loads and runs the Python code at the fog node as well as the YOLO engine and the Python code at the edge side. This is the Python code at the fog side. We can see that it's awaiting deployment from the bus. As soon as the bus deploys the ZDM instance, the Python code runs at the factory side. Same applies for the edge node. This will instantly trigger the ZDM system to run without any human intervention at the factory side or the edge side. After running the scripts, the production line starts working, where the robotic arm picks up and places products on a running conveyor belt. In this scene, we can see the robotic arm placing a monocolored cube on the conveyor belt. At the edge side, the object is detected as non-defective. A command is sent to the factory side instructing it to keep the object on the conveyor belt. In this scene, however, the robotic arm places a cube with black circular marks on the conveyor belt. We can then see the edge node identifying this cube as defective. A command is sent to the fog side instructing it to stop the conveyor belt and then remove and dispose the defective object. In this scene, we can see the full setup running, with the objects being placed on the conveyor belt, the video being streamed towards the edge node using the 5G network, the categorization of the object, and the automated control of the factory.